everyone. Thank you for the opportunity. My name is LalithSriram. I work as a cloud engineer at one of the largest healthcare companies. So today I'll be presenting the topic on signal-based anomaly detection in a cloud operations using log insights and Prometheus metrics. So in this topic, I'll walk you through the problem we are addressing and the approach we have developed and how it's implemented in the practice and why these matter for the modern cloud environments. I'll just begin with the introduction and outlining the problem as well with the traditional monitoring things, and then we'll look at the system architecture, and then followed by what roles played by the log insights and the Prometheus. After that, I'll be explaining like how we extract the signals from the logs and the detection we use, to identify the anomalies as well. Then I'll walk you through implementation flow and share some key challenges as well, what we've finalized and summarized for the future directions and the conclusion as well. So let's move on to the introduction. So as a cloud native environments, continue to grow here, which we are built on microservices, containers, and dynamic orchestration platforms. So they generate enormous volume of telemetry data, like logs, metrics, and traces. That system automatically generate these things. So monitoring these complex systems with traditional methods becomes much more difficult. Most convenient strategies rely on like a fixed thresholds or an isolated log analysis. So these are like no longer effective in the dynamic environments now with the constant changing workloads. So these leads to like two major problems: flood false positives, which overwhelm the engineers, or we face like missed anomalies that could prevent more outages as well. So these issues reduce the trust in the monitoring tools and then slow down the response time as well. So to address this gap, so organizations are shifting towards a signal based anomaly detection and an intelligent approach that correlates logs and metrics in the real time. So by using the tools like log insights and Prometheus, we can detect the real behavior pattern, and which has a reduced noise that is built my more resilient way, more responsive observability system. So now let's take a look to the end-to-end architecture as well. The pipeline begins with the application and the infrastructure level, where various services are generating unstructured log data. So these logs include everything from the system events, error messages, to the API responses and the authentication logs as well. So to collect these logs effectively, we use like a Fluentbit, which is a lightweight, high performance log shipper. It continuously streams the logs from the distributed systems or services and sends our logs to analysis system here. So then coming to the next critical component is a log insights, the tool which is responsible for parsing the incoming raw logs that are identified recurring patterns known as indicator of anomalies as well. Instead of treating the logs as a plain text, log insights extract the semantical meaningful signals such as authentication failure or a database timeout or service unavailability, so which converts in a human readable thing. These signals are then structured and quantified. For example, how many number of timeouts per minute are and also exposed to downstream monitoring tools such as structured metrics. So what makes this architecture more powerful as its modularity? Each component from the log collection to signal transformation, it is loosely coupled, meaning it can scale independently and integrate with the various technologies as needed. So this flexibility, right? So it's critical in the dynamic cloud environments where we have workloads, tools, and infrastructure, and they changes the frequently. So So here, Prometheus. So here, I mean, like Prometheus plays like a central role in our detection system. So it continuously scrapes the structured metrics we just discussed and stores them in time series data. These metrics are tracked over time to establish baselines and to spot the deviations which are from expected behavior as well. So what makes the Prometheus especially powerful, the ability to detect multiple strategies. For example, we can say it has like a rule-based thresholds for well understand issues like triggering the alert for the error rates which exceeds, like for example we can say 5% or a 5 minute window. Or and one more thing is like a statistical models such as uh, moving average and z-score analysis as well to detect the outliers and the noise resistant anomalies. And even the machine learning based techniques like forecasting or clustering as well. So for instance, when an anomaly is detected, Prometheus sends alerts through alert manager, when then forwards them to a team communication tools like Slack or PagerDuty. So this ensures that the right team is notified in the real time when we need to act as a quickly. So what's important here is not just an early detection, but the context aware detection. Since these metrics were derived from the log signals, these alerts carry more meaning in which service endpoint or user activity caused by the spike. Like, so engineers don't waste time digging the raw logs or figuring out like which log in the notepad. So, and in many cases, right, so these can be integrated with an automated responses as well, like restarting the failure pod or scaling up the resources, or triggering the rollback insights as well. Now let's move on to the uh, log insights. So log insights are one of the richest sources of operational intelligence in distributed systems. They capture granular real-time details about like application flows and service interactions or user behavior. But in practice, logs are often unstructured, like noisy, or more we can say like more voluminous, which makes difficult to interpret these especially during the special when you are in the pressure or during an incident arises or an escalation comes. So simply storing these logs and searching through manually isn't enough anymore. So that's the first step in our signal based anomaly detection approach, which to know the pairs logs intelligently and extract them semantically meaningfully to the patterns. So instead of treating the logs as a static text files, we use a pattern matching in some cases, like natural language style parsing to detect signatures of abnormal behavior. For example, we can see the common patterns like timeout while connecting to the database, or user login attempt failure, or the service unavailable upstream error. So now let's focus on the role of Prometheus in this architecture. So once we extract the signals from the logs, the like login timeouts or API errors, they are passed into like a Prometheus as a time series metrics. So this it continuously ingests these signals and stores them with a high resolution. So this gives us like not just a real time view, but also ability to perform the historical trend analysis over weeks or over even months as well. So as a key capability here in a real time anomaly detection, Prometheus watches for spikes or unexpected changes in these signals. So as they come in, like for example, if the login timeout rate usually hovers around like 2 minutes per, 2 minutes, but suddenly jumps like into 15. Then the Prometheus detects that the deviation using rolling averages or historical baselines. Uh, but I mean, like, what even more powerful is ability to monitor the behavioral trends over time. Let's say, like, our system is typically experiencing a traffic spikes on every Monday morning. So let's say the Prometheus learns this pattern and won't treat it as like in an anomaly. However, if the spike comes through earlier or lasts long than casual, it can be a flag, and it could be a potential issue. So beyond just storing and analyzing the metrics, Prometheus provides like more powerful capabilities like querying, alerting, and visualization as well. All of these which are essential for let's for the operations team. So first, let's talk about querying and correlation as well. So Prometheus uses like a PromQL rich query language that allows us to filter, group, or analyze the metrics across the service. So with PromQL, we can write up the queries like we just need to don't ask like did the signal cross a threshold, but also it's like is it happening across the multiple services at the same time? We can ask this kind of questions for that. Is for one more question is like is it this a recurring pattern that aligns with the other behaviors as well? So this allows us to correlate the multiple signals and spot the compound anomalies that signal metric tools would easily miss it. So now let's move on to intelligent alerting. Prometheus can be trigger alerts not only when the threshold is crossed, but when the signal behaves norm abnormally compared to compared to usual trend as well. So it integrates with Alert Manager, which routes alerts to systems like Slack, PagerDuty, or the PagerDuty has a good option. We can integrate with the phone as well. You can get a call when the alerts are triggered. So ensuring the right people are notified quickly with the context. So finally, all of this is tied together with a visualization. So Prometheus works natively with the Grafana as well, so which allows teams to build like intuitive dashboards as well. So these dashboards are essential. They give us for engineers, they gives us real time view of what they were happening in the highlights. A form of a view. So in short, like Prometheus is not just a data collector. It's like it's an analytical brain of our monitoring pipeline, which drives both accuracy and early warning as well. So now let's focus on the most important step in our pipeline, the signal extraction. So the signal extraction is a process of turning the raw, unstructured log data into a meaningful, quantifiable metrics that can be monitored in the real time. So instead of looking at the logs as an isolated, text entries, we identify the key pattern like errors, timeouts, and the performance warnings, and then convert them to structured signals. For example, if you have the logs show like repetitive entries like as we discussed, timeout connection to the database or user login failure. So these signals are exposed to the metrics that Prometheus can ingest, store, and analyze at one. So this transition is critical because it allows us to move from quantitative of log narratives, which to machine readable metrics. It makes the data easier to visualize, monitor, and alert on. Now let's move on to what we have extracted the structured signals from the logs, and the next step is to analyze those signals, right? So that's where the detection model kicks in. So the detection model is like analytical techniques which are used to design or identify the deviations from what expected behavior is. So these models range from basic rules to more sophisticated algorithms as well. So one of the simplest is like a static threshold model, which is a straightforward model. For example, if your error rate is like exceeds 5% more, the system flags it. So while this statistical is very easy to implement, but they can miss out some context, like that's where moving, averages comes in. So with this model, the moving averages model, the system monitors how signal behaves over time, comparing current trends or the spikes. If a sudden spike occurs, that's significantly higher than a shorter or long-term average. It's flagged by the anomaly. So this makes like more moving averages much better suited for the dynamic environments where workloads and baselines shift frequently. So now let's building on like the previous models, like let's take like more advanced anomaly detection techniques. So first we have z-score analysis. So this statistical method flags an value that deviates significantly from the average thing, based on like how many deviations it falls up. So it's particularly used for catching the spikes or drops that aren't obviously terms, but we are unusual behavior in the historical behavior. So next is like seasonal trend decomposition. This method breaks the signal down into like components. So the overall trend and repetitive seasonal patterns and the residuals, what are left. So by isolating these residuals, we can spot the true anomalies, even in the systems where it contains like fluctuations are expected. Like for example, like traffics are in the peak hours or during the business hours. We can say like it can be detected during the high business hours or dips at the nights as well. So finally we have one more machine learning model based. So these offer like a more flexibility and power when the system behaves complex or constantly changing. For example, we can say like unsupervised clustering algorithms like k-means to a group of signals with similar patterns that detect like anything that doesn't fit. So our forecasting models like LSTM, short term memory, to predict what signal should look like, or the flag deviations in the real time. Now, let's jump into the real world implementation of the pipeline. It starts with a log injection. Logs are continuously collected and passed through using the platforms like Log Insights, which helps us to identify the key patterns as well. So these patterns are aggregated and converted into the structured signals. Then these structured metrics are pushed to Prometheus, which were stored in the time series data as discussed earlier. So once inside Prometheus, we can apply a range of detection models, starting from statistic thresholds and rolling average, and we can move to more advanced like z-scores or even machine learning models as well. So when these anomalies are detected, alert manager kicks in, and then it triggers like notifications, typically to route it to a Slack or a PagerDuty. So these alerts can be visualized through a Grafana dashboard as well, by providing operational teams with real-time visibility, and what are the current trends or historic trends on this one. So now let's move on to the evaluation to validate this effectiveness of the anomaly detection system. So we started with the data set that includes a pre-identified anomalies, things like latency spikes, or known error surges, or stimulated service failures. Our goal is to test whether the detection models could correctly flag these events, or how well they perform under these conditions as well. So the core metrics we were using is like a precision, recall, and F1 score. So the precision, which tells you how many alerts which we are raised that are actually correct, helping us to measure the system ability to avoid the false positivities. And coming up to the recall, which tells like how many real-time anomalies were successfully detected, showing up the system sensitivity. And the last one is like a F1 score, which balances both like a precision and recall as well to give an overall picture of the detection accuracy. So in the more advanced scenarios, we also review like ROC curves and AUC curves as well, which helps visualize this trade-off between like true positive and false positives as well. So this evaluation, I mean, like loop helped us to refine our detection rules, which has been reduced noise and most importantly to build trust on this monitoring system. So these alerts are taken seriously when we happen on this one. So this is a simple sample flow chart for test data and detection results as well. So now let's move on to the challenges and the future work as well. So with as we have a real world implementation, we have encountered some challenges, particularly when we work with logs and signals at a scale. The first challenge is like log format variability. Suppose when we considered Amazon or any top tier companies, it has like large cloud environments. So logs can be come from variant different services or different teams and different environments as well. So each has their own format or structure or the visibility. So this makes like it's really difficult to define the universal parsing rules that extract the meaningful patterns consistently. So as a result, we spent, I spent on a significant amount of a time on normalizing and parsing tuning. So which increases the engineering overhead and the maintenance as well. And the second major challenge is like the signal ambiguity and the noise. So not every log entry that looks unusual is truly actionable. What I mean is like many times a spike occurs in the errors or the timeouts. It's a temporary that resolves itself without any human intervention for like 1 to 2 minutes or like until max is the 5 minutes. So yet these get still flagged as an anomalies, right? So continuing the challenges, the next issue we faced is like manual threshold tuning. While the static thresholds are easy to set up, they don't scale with the modern dynamic environments. So as this workload shifts throughout the day or week, right? So we have like a 24/7 operations. So a fixed threshold can either result in alert fatigue because it fights too often or it completely misses the animal just like that we just felt below the limit. So tuning these thresholds manually becomes like more time consuming and a trial and error process, and it's not sustainable for the system growth. That leads us to the next challenges, scalability and the performance. So as more signals are extracted and monitored, so like tools monitor tools like Prometheus can begin to structure this high cardinality long term storage and real time querying as well. These high resolution metrics across hundreds of services generate like huge amount of data and then adds a load to the system that makes slower to respond or it makes it like more expensive to operate as well. So the last challenge is like so one of the most critical gaps is lack of casual correlation. So right now the signals are more often evaluated in the isolation, but in real world incidents, usually we involve a combination of factors like for instance, like latency spike tied to the deployment or a database alert that flows to an upstream error. So these are the challenges. And coming to the future work, looking ahead, like there are like server keys we are exploring to make to make the system even more adaptive and intelligent. The first one is like machine learning based dynamic thresholding. So rather than relying on like fixed rules or manual tuning, we closely apply like unsupervised learning and time series forecasting models like ARIMA or LSTM. So auto-regressive integrated moving average or a long short term memory. So these techniques can learn the natural rhythms of our services and automatically adjust the alert thresholds based on the historic behavior and the workload patterns as well. So these significant this would be like significantly reduce the noise while increasing the system's sensitivity to the real anomalies as well. The second area is like a cross signal correlation. Today, we often monitor like metrics or traces in parallel, right? So, but not always together, right? So by correlating these signals, we can uncover much more richer insights. For example, like if we notice what you can say is like a timeout area or like a timeout rate, then we can see this from the traces that it correlates to an upstream memory exhaustion. So which is much which is much clearer path, I could say. This level of correlation is key to better, to the root cause analysis and smarter, alerting, we can say. Finally, we want to implement the feedback loops, for the incident response as well. So this means like taking what the SRE team is a site reliability engineer that learns from the post incidents reviewers or feedback that's based on our signal rules and the anomaly classifiers as well. So in addition to this smarter detection and correlation, so we are also looking at the several innovations and that improve our automation and usability as well. First is like auto signal generation using NLP, natural language processing. Right now, like the most signals definitions, right, are like required engineers to manually define the log patterns. So but with the NLP models, we can continuously detect and classify the newly or previously unseen logs patterns, right? So once we feed the data to the NLP, so essentially these generating signals are on the fly to reduce this engineering effort, right? So it adapts quickly to the evolving systems and catches the anomalies that the traditional rules might miss out, right? So next we can say is like next is like a push for a standard telemetry pipelines using a framework like like OpenTelemetry. Today the log metrics and the traces are often collected by different agents formats. It could be different formats as well. So OpenTelemetry provides an unified way to collect and enrich and export all the observability data across all the platforms. So this increases the compatibility and reduces the vendor lock-in, or to make the system wide observability as much as to streamline the operations as well. So finally, we are focusing on the visualization and the expandability. It's not enough to know like that an anomaly happened, or we need to know like why it happened. Like in the future, I mean like the future interfaces will include contextual dashboards as we discussed earlier. So it can be like used Grafana here, and which shows like signal triggered alert at what time at particular alert can be compared to the baseline. So it could potentially the root causes as well. So let's move on to the conclusion. To summarize, signal based anomaly detection represents much more forward in the observability. Instead of relying on the traditional reactive or rule-based alerting, so we are moving towards proactive, adaptive monitoring approach, I could say. which uses that real-time behavioral insights. It's just not a fixed thresholds. By extracting these structured signals from an unstructured logs, um, uh, you know, uh, and them analyzing them in a real time using Prometheus, which teams gains much more deeper insights and how their the system behave. This method helps to reduce the alert noise and improve incident response, and we can say, like, this lays out groundwork for the more intelligent as well, even self-healing cloud native systems as well. So as telemetry continues to grow in the volume, and adopting a signal-based driven strategies will essentially build resilient and scalable operations coming forward. Thank you, everyone.